Okay, imagine an alien intruder just crashing through our solar system, completely ignoring all the local traffic laws and fundamentally challenging everything we thought we knew about the universe. Welcome to The Explainer. Today, we're diving into the ultimate cosmic detective story, decoding the very first mid-infrared chemical fingerprint of an object that was born in a totally different stellar system.
Now, to really grasp this, you have to look at the sheer mind-bending speed of this thing. Interstellar Comet 3I/Atlas came hurtling past our sun at a staggering 210,000 kilometers per hour. That completely blows past previous interstellar visitors like Oumuamua and Borisov. Because it's moving on this extreme hyperbolic path, we are literally getting a one-time-only flyby. It's a messenger from the deep void, and once it's gone, it's never coming back.
And that brings us to the massive mystery we're trying to solve today. What actually happens when a chemical time capsule, potentially up to 11 billion years old, pays us a one-time visit from another star system? Well, as you'll see, the data we managed to grab during this ridiculously brief encounter is completely rewriting the rules of astrochemistry. It's giving us a front-row seat to how alien worlds actually form.
All right, let's get into Section 1. The alien intruder arrives. So back in July 2025, the Atlas survey spots this thing and it immediately sends absolute shockwaves through the astronomy world. Why? Because it's only the third interstellar object we've ever definitively confirmed. But it wasn't just where 3I Atlas came from that had everyone hooked, it was how it was acting. It activated, started glowing and venting way earlier than standard comets do. That immediately told us it was packed with highly volatile ices that were boiling off even when the sun's heat was still super weak.
And honestly, its physical behavior is downright bizarre. We're looking at an object up to 5.6 kilometers wide, and it is actively defying the laws of cometary physics. Here's the crazy part. Despite boiling off massive amounts of gas, it shows absolutely zero non-gravitational acceleration. Normally, when a comet vents gas, it acts like a little rocket thruster, physically altering the comet's path. But Atlas? Nothing. No recoil whatsoever. And that presented us with a profound structural puzzle right out of the gate.
Which leads us to Section 2, a coordinated cosmic stakeout.
Okay, so to catch this fast-moving thief, humanity had to pull off the ultimate cosmic flex. In November 2025, we got this incredibly lucky astronomical alignment. As the comet zipped between NASA's Europa Clipper and ESA's JWST spacecraft, we were able to capture the dusty night side and the glowing day side at the exact same time. Clipper was looking at the scattered dust in the dark, while JWST was analyzing the glowing gas on the sun-facing side.
And get this number. JWST's instruments recorded the comet dumping 2,000 kilograms of water every single second from its day side. That is literally 2 tons of water per second. But the data revealed a really wild twist. A huge chunk of this water wasn't actually coming from the main comet nucleus itself. Instead, it was sublimating off these tiny, icy dust grains floating out in the comet's atmosphere.
All of this explosive outgassing created a debris trail that is just hard to wrap your head around, stretching over 5 million kilometers into the void. But for astronomers, this was a dream come true. It basically set up this sprawling 5 million kilometer long laboratory of alien chemistry, perfectly positioned for our biggest telescopes to tear into.
And that takes us to Section 3, Webb's Forensic Chemical Autopsy.
Operating out in the deep freeze of space, the James Webb Space Telescope managed to successfully lock on to this incredibly faint, incredibly fast target. And the spectral map it sent back, it confirmed that Atlas was born in a cold, uniquely carbon-rich stellar nursery. The chemical makeup we're looking at here is totally alien compared to the comets born in our own backyard.
Just look at this breakdown. The data shows a shocking 8-to-1 ratio of carbon dioxide to water vapor. That completely breaks the models we use for standard solar system comets, where water ice is usually the star of the show. In 3I Atlas, carbon dioxide is overwhelmingly driving the engine, which heavily hints that its internal structure is keeping water frozen deep, deep inside, while the CO2 just burns right off.
But wait, it gets even weirder. Alongside that massive CO2 spike, Webb and the other observatories found complex molecules like methane, carbonyl sulfide, and nickel. Yes, trace metals. Finding a metallic component like nickel in a comet is exceptionally rare. It strongly points to a history of high-energy shock heating inside a metal-rich, distant alien protoplanetary disk. On top of that, Polarimetric studies, which measure how light scatters, showed a 2.7% negative polarization inversion. Now in plain English, the way light bounces off this dust implies it's structurally alien. It tells us these dust grains might be unusually tiny, have completely bizarre surface textures, or be just incredibly porous compared to solar system dust.
All right, let's dive into Section 4, Secrets of an Alien Sun.
So what does this extreme chemistry actually tell us? Well, the massive concentration of carbon proves this object absolutely did not form in a water-rich zone like our native comets. Actually, it formed near an extreme CO2 ice line, orbiting a star completely unlike our Sun. The specific balance of gas, dust, and ice points to a stellar nursery with totally unique temperature and pressure conditions.
And the implications here are just huge. We already know from sampling pristine rocks in our own solar system, like the OSIRIS-REx mission to Bennu, that ancient space debris carries the exact precursors for biology. We're talking the 5 canonical nucleobases for DNA and RNA, 14 protein-building amino acids, formaldehyde, the whole shebang.
Danny Glavin from NASA really hits the nail on the head with this idea. If local comets and asteroids seeded our solar system with the ingredients for life, finding an interstellar visitor like 3I Atlas scales that concept up to the entire galaxy. It's hard proof that these complex, carbon-rich delivery systems are out there zooming across the Milky Way right now, potentially delivering the raw ingredients for life.
Let's wrap things up with Section 5, the ultimate cosmic time capsule.
Based on its trajectory and that ridiculous speed, astronomers estimate this comet is a chemical memory book that could be up to 11 billion years old. Think about that for a second. That makes it a literal fossil from the Milky Way's earliest eras. It could actually predate our entire solar system, carrying the frozen chemical memories of a stellar environment from when our galaxy was just a baby.
And honestly, consider the impossible gauntlet this chunk of ice had to survive just to get here with its gases intact. It was likely violently ejected from its home, maybe by a binary star or massive planets migrating. Then it spent billions of years getting blasted by cosmic rays, eroded by micrometeorites, and subjected to extreme thermal cycling. Yet somehow its deep chemical reservoirs survived totally undisturbed until it met our Sun.
So as 3I ATLS completes its flyby and vanishes back into the cosmic void forever, it leaves us with one final, chilling thought. What other ancient secrets or catastrophic messengers are speeding toward us right now, hidden in the dark? The universe is incredibly vast, and as we've seen today, it is actively delivering its deepest mysteries right to our front door. Keep looking up and stay curious.